When I was younger, I was still interested in higher dimensions, but it was a very small interest as it was impossible to find good stuff about it online. I came across many videos explaining how 2D and 4D work, and they often got 2D very wrong. This is because of the popular book Flatland, which I don't think the creator was trying to be scientifically and biologically accurate, and if they were, I worry for their mental capacity. Anyway, the videos I came across, while they didn't technically say that they were physically accurate, they did imply it, and it's definitely a thing many people actually believe. When I was younger, I did as well. So I'm making this video to show how things actually work. Whether or not the videos about Flatland count as misinfo is up to you to decide. Part 1. Directions. In Flatland, the plane is set perpendicular to gravity and the inhabitants are free to move around without having to push off of anything or expel propulsion. This is obviously unrealistic, but something less obvious is that Flatland should have gravity. If life were to emerge in 2 dimensions, it would need to most likely be on a planet in order to get complex enough biochemistry, in which case there'd be 1 dimension of ground and 1 of gravity. This is not strictly necessary, after all it's a fictional concept and artists are free to do whatever, but just remember, if you make something about 2D and there's no gravity, it must be in space. Even if you say it's not, it is. This video is about science, not art by the way. Flatland wasn't really trying to be a scientifically accurate book, but there's a book that was. This is the Planiverse, a far more realistic speculative evolution take on 2-dimensional space. And here's my project, which is also more realistic. It's somewhat inspired by the Planiverse. This is a very small project, but if people show interest, perhaps I'll do an in-depth video on them. Part 2. Light. Oftentimes you'll see Flatland videos dim things as they get further from the camera. The reasoning for this is a misunderstanding of the inverse square law. Or they just don't care about scientific accuracy and did it to make things easier to tell apart. I'm not really sure. Probably depends on the renderer. What is the inverse square law? Well, imagine we have some point radiating energy. If you sample this energy at any given distance, you'll get some level of energy back. Remember this energy and call the distance you sampled from 1 unit. This works independent of units. If you now measure at twice that distance, or 2 units, you'll capture 1/4 of the energy. This is because 1 over 2 squared is equal to 1/4. If you measure it 3 units away, you'll measure 1/9 of the energy of the 1 unit measurement, because 1/9 is 1 over 3 squared. This is the inverse square law. Energy at radius r equals energy at radius 1 over r squared. The energy of the whole system stays constant, but the area increases so the density, what we can measure, goes down. No energy is lost. In 2D, it's the inverse linear law, since a circle's circumference grows linearly with the radius. So wait, if the energy density goes down, and so our eyes perceive less energy from further objects, why don't further away objects appear darker? Well, as something gets further, less energy reaches your eyes, but it also has less area on your vision by the same rate, making it brighter again by the same amount. In simpler terms, the density of light hitting your eyes is brightness, and the area is the visual size of an object. Meaning, further objects shouldn't look darker, they should look smaller. I know this is obvious to anyone with eyes who grew up in this universe, but it's fun to explore and explain the math and physics behind something, especially when you're speculating on different universes. What about 2D? Well, nothing changes. The inverse square law is now inverse linear, but the size of objects in your vision is now measured in length, not area, and that has a linear relationship with distance too. Applying perspective projection already makes objects lose energy. By artificially darkening things, you're applying the effect twice, which as I just explained is mathematically and physically incorrect. The inverse square law is an observation about how things work. By applying it again, you're just redoing what's already been done. Part 3. Vision. So what then? Are Flatlanders screwed? Can they just not ever tell shapes apart because they see featureless lines? Well, think about 3D. When you see a shape, further parts aren't darker, but you can distinguish them because textures on them distort, and lights create shadows and highlights. The same would happen in 2D. My renderer doesn't show textures, but it does show how the bottom of a shape would get less light than the top. This is what Flatland actually looks like. It's a vertical line, and there's no fog, only shadows. Here's another example with a different renderer that does show textures. This is a simple little 2D Minecraft clone. It's not done yet, or even like playable, but I do have a little stone world that I can walk around in, and this is what Flatland actually looks like. I think this is really cool. And there's the 1D textures, and then to look to the other side, I have to look up, and now the world is going to be upside down, and then the camera flips back around. And also here you can see there's a little bit of a shadow. Yeah. Thanks for watching. Please let me know if this video is simple to understand. I really tried with the visuals and script on this one.